Welcome to EDU World Space.
24.66. We have two concentric conducting spheres with the given charges sitting on them. So we want to find the electric field at a bunch of points and the potential at even more points, and then sketch what the electric field and the potential look like. So we can figure out the electric field using Gauss's law. This is spherically symmetric, and we already know that if you have a spherically symmetric distribution of charge, that outside of it, it looks like a point charge with the same charge. So we can just write this as a piecewise function. Inside the inner sphere, there's no electric field because there's no charge enclosed. It's going to be kq1 over r squared for radii in between the two spheres. And the same thing, but with the sum of the charges outside of them. And similarly for the potential, it's going to just look like the potential for a point charge. So it's going to be kq1 plus q2 over r if we're outside of everything. kq1 over r if we're in between the two. That's not quite right, actually. kq1 over r plus the potential we already got from arriving at r2, which is just q2 over r2. And then inside it's going to be just this constant. So we have this written down now. And so using that and the numbers here, we can just start plugging things in. So this will be 1.69 times 10 to the third volts per meter at 4 meters. At 0.7 meters, it will be 3.67 times 10 to the fourth volts per meter. And now we're inside the sphere, and the electric field will be 0. Excuse me. So at 4 meters, we're going to have 6.74 times 10 to the third volts. At 1 meter, we're going to have 2.7 times 10 to the fourth volts. At 0.7 meters, we'll have 3.47 times 10 to the fourth volts. At half a meter, we'll have 4.5 times 10 to the fourth volts. And then inside of the inner sphere, we'll have 4.5 times 10 to the fourth volts, because this was already at R1. This is less than R1. And again, at R equals 0, we're less than R1. So this will be the same again. And so if we sketch this, here's the electric field. It goes from 0, this is at R1, and decreases a bit at R2. It has a jump because we're enclosing more charge all of a sudden, and then it goes as 1 over R squared after that. Now our potential is going to be constant, and then just decrease like 1 over R, because we don't have any discontinuities in this function, which you can prove to your own satisfaction by looking at what happens at the radii of the two spheres.